So in this lecture, we're going to be speaking about partial fractions. So let's go ahead and get started. So this is used for integrating irrational functions. So we have the integral of p of x over q of x d of x. So the rational fraction p of x over q of x is proper if the degree of p of x is less than the degree of q of x. So for instance, in this first example, you have x to the power of 1 divided by plus 1 over x squared minus 2. So we can see that the numerator power is less than the bottom. In this case, it is proper. If we have this second example, the both of them are equal. So in this case, they are not proper. And if you have also the degree of the top is less than the bottom, again, it's a proper fraction. This is an improper since the numerator value is bigger than the top. Then each proper rational function can be written in this form, which is p of x over q of x is equal to f1 x1 plus f2 x2 plus so on plus fn x. So each of fi has one of the two forms, where a over ax plus b to the power of k, or ax plus b over cx squared plus dx plus e to the power of k, into smaller, simpler fractions. So these two are factors of q. So each factor of the type ax plus b can be replaced by these. In this form, where you have to write, first of all, your a1 over ax plus b, then your a2 plus your ax plus b, then squared, plus so on and so forth. Like, for example, your a3 over ax plus b cubed, plus your ak divided by ax plus b to the power of k. Then you have each factor of the type cx squared plus dx plus c to the power of k can be replaced by these, which is a1x plus b1 over x squared plus dx plus e, plus the second part, which is a2x plus b2 over cx squared plus dx plus c, all of this squared, plus cx plus bx over cx squared plus dx plus e to the power of k. So if it's proper, we use those two rules. If the function is improper, we have to divide, which is log division. So each proper rational function can be written in this form. So for example, in this example, in this one, we have x plus 1 over x squared minus 4, and this is the integral d of x. So we use the first rule, which is x plus 1 over x squared minus 4. So we have to divide it into two brackets, which is x plus 1 over x plus 2 and x minus 2. Then you have to put it into two separate parts, which is ax over x plus 2 plus b over x minus 2. So we multiply both the sides by x plus 2 and x minus 2. So x plus 1 is equal to ax minus 2 plus bx plus 2. And then you can simply expand the brackets, find your a, find your b. Then you have your 1 is equal to 1 minus b plus 2b, and then so on. So b is equal to 3 over 4, or a is equal to 1 minus b over 4, which is 1 over 4. Then you have your whole integral equation, which is x plus 1 over x squared minus 4 is equal to the integral. You plug in the values that you've got from the equations, and then you can integrate normally. So 1 over 4 is equal to ln x plus 2 plus 3 over 4 ln x minus 2 plus c. Then you have your example b, which is integral of 4 over x cubed minus x squared d of x. So you have your a, b, c values. So your a, b, and c values. Then you have your a, then you have your b. You put in the integral, and we know that you can put the 4 outside as a constant. So it will be minus 4 ln x plus half ln plus half minus ln x minus 1 plus c. All right, another example here you can have, which is x to the power of 5 minus 4x cubed plus 1 over x cubed minus 4x. So when you integrate it, you have x cubed plus 1 over x cubed minus 4x. So this is a proper rule, and then you can basically do long division. So x to the power of 5 minus 4x cubed plus 1, and then you put outside your x cubed minus 4x. So when you do long division, you have to divide the first part of the variable. So the x to the power of 5 divided by x cubed is x squared. And then you can simply multiply each part. So x squared times x cubed is x to the power of 5. X squared times negative 4x is minus 4x. Then you'll basically subtract. So x to the power of 5 minus x to the power of 5 is 0. Minus 4x cubed and minus 4 x cubed is also 0, and then you will put the 1 as a remainder. So when you write it, it will be x squared plus 1 divided by x cubed minus 4x. So you will have here your x to the power of 4 over 4 plus the integral of 1 over x open brackets, x squared minus 4 d of x. The integral of 1 over x squared minus 4 d of x, you put it into 3 main parts. So a over x plus b over x minus 2 plus c over x plus 2. So we'll have your 1 is equal to a x squared minus 4 plus b x plus 2 plus c x minus 2. So you will have your 1 is equal to ax squared minus 4a plus bx squared plus 2bx plus cx squared minus 2cx. So you find your a, your b, and your c. Then you put it in there and then you will integrate. And from there it will be your x to the power 4 over b plus 1 over 8 ln x squared minus 4 over x squared d of x. So you will simply just like differentiate overall. So this is it. And then I will show you some examples on how you can also solve partial fractions and various examples in the seminar. So I'll see you in the next seminar.